Hello everyone, this video talks about the implementation of the LPOD workflow scheduling algorithm in data view system. This is the second tutorial. The first one is ICPSP, and the terminology used in the LPOD is same with the ICPSP. So we also have the execution time temporary and age map temporary. These two variables can be initialized based on the workflow configuration file, and which is the JSON file, and we have the task name and followed by the virtual machine running type associated with the task execution time in different virtual machine types, and also we have the data transfer time associated with the data size and the age between the two tasks name. Then we based on these two variable, and we can initialize the age map and execution type variable. So then we also have the node parents, and which is initialized in the workflow structure, and we have the top logic order. So the top logic order is used to calculate the upper rank value for each task, and the upper rank value is used to create the particular critical path, which is called PCP. And we also have the task time, and we have the minimum execution time, the earliest start time, earliest finish time, and last finish time. And also we have the virtual machine tabs, and we have the local schedules, and we use a 0 to represent the entry task, and -1 to be the exit tasks. And we have the deadline D, and we have the time interval, and we have server cost, and we have the virtual machine delay time. And we also have the class VM associated with the virtual machine type, available time, current virtual machine lab time, and provision time, deprovision time, and the task running this virtual machine. And also we have the another class, task class, and with the task ID and actual start time for this task and actual finish time for the task. Then in this case, and we can have the workflow schedule SH, and including all the tasks and all the virtual machines. So for the workflow planner constructor, it takes two. First one is workflow W, and the second one is the workflow configuration file location. And then based on the workflow configuration location file, and we can extract the execution time temporary and age map temporary. So the difference between the two, the SPCP and the pod is the plan master. So let's go to the plan master. Then we have first we have the age processing. The age processing is to initialize the age map, and the age map is also based on the workflow age, and associated with the age map temporary. Because we can, based on the age map temporary, to get the transfer time, then we just put the information to the age map. Then the second one is the get task execution time. So we were based on the age execution temporary to initialize each execution time. Then we can next step is we get priority value. How we can get the priority value? So so this is the formula to how do we get the priority value. So as we can see here, we first we need to do a topological sorting for all tasks in this current workflow, and we start from the last task for the topological order, which should be the entry task, the exit task. Then we put the priority value for the exit task is 0, and then so we start from the center task, and we get all the children for the current task, and then we can based on the max notation, and we can select the max value by including the priority value for the children plus by the data transfer time. After this part, and we can plus the average execution time. Then we can put the value to be the priority value for the task. So far, we can calculate all the priority value for each task. So the next step is we can do a sorting. The priority value in a descending order. So the next step is we build task time, and this is the same way we do in the SPCP, and also the next step is, let's go to the ARX1, right? So we have finished the 1, 2, 3, 4, and we'll go to the 5, and we find all the PCPs, and after that we can call the passes assignment, the PCP. How we can get all the PCPs? So this is the how we can get all the PCPs. So first we get all the tasks based on the sorted priority value, and then we add all the tasks into a list. Then first we want to remove the exit task, because so this task is already assigned. Then we can in the while loop is how we can get all the priority value is corresponding to the pseudocode of the while loop, and so by the end, so we can get all the partial critical passes, which are called PCP. So the next step is the assignment, right? So this is pass assignment. So we also show the pseudocode in the left side, and so you can see here the LJ will use LJ to be a indicators the prefix of the path, which can be assigned to the existing virtual machine, since by this kind of condition. So if we can find the LJ, so it means that so the one subset of the path can be assigned to the existing virtual machine instance. If not, so the LG is 0, so the subpass is the original pass. So we are called the pass assignment to the subpass, and after that, and we can see here for each pass, and we are updated the task time, and however we also need to we are updated the actual start time and actual finish time. So also the minimum execution time is updated to the actual execution time. So we're updated the successor and updated the predecessor, which is same logic in the ICPCP. So the important part is the pass assignment. So in the pass assignment, so we will the pseudocode is we will use the TB, right? So but we don't have the TB, so we'll use the several 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll use non-released to represent the TB. So we have the ID, we have the task, we have TST and TFT, accumulate cost and T left, and ID reference, max age, and VM type. And so this is the first task in the pass, is from the for loop to the end. So all this part is we create. We just fill these values in the non-array list, right? It's associated to the line 2 to the line 8. Then we select the smallest value. So we will get the last task, and then we will get the last task first index, and we'll get last task last index, and then so we have the range. So then we can create a sublist which has the which will store the accumulated cost. Then we can get the index of the smallest value of in the accumulated cost. Then we can have the so the smallest is the index of the ID, and we can also based on the ID reference, and we can have the pre-index. So in this case, and we can traverse back how we can calculate from the very last task to the first task in the pass. So this is how we can do the update. So you can you can see the source code, and you can associate with the pseudocode in the from the line 19 to the 46, from the line 493 to the line 53. So this is how the assignment pass works. And the LPOD is we have show you every details and very every equations in the paper, and it's very easy to understanding. So if you have any question, you can email me. Thank you.